So today we're going to be teaching about the law of combining volumes. Basically what the law of combining volumes is when measured at the same temperature and pressure, volumes of the gaseous reactants and products of chemical reactants are generally simple ratios of whole numbers. To begin, we will use the example N2H4 liquid plus O2 gas, which react together to produce NO2 gas and H2O gas, which is water vapor. Before we can continue, we need to balance the equation. So on the left side, you have N2H4 liquid plus O2 gas. And then to balance, you'll have 3 oxygens on that side. Then you go on the right side, you'll have 2 NO2 gas plus 2 H2O gas. Then, after you've balanced the equation, you will need to find the amount of moles in each molecule. So in N2H4, you have 1 mole because there is no moles in front of it. There's no number in front of it, so it just means that there's 1. In oxygen, you have 3 moles because it tells you that you have 3 in front of it, so that just means there's 3 moles. And then same with NO2 has 2 moles and H2O has 2 moles. These also are the same when you're looking at volumes of these molecules. For the volume of N2H4 would be 1.0 liters of N2H4, and then oxygen would be 3.0 liters of oxygen, and then NO2 would be 2.0 liters, and then H2O would be 2.0 liters of H2O.
Now we will talk about the Avogadro's theory. The Avogadro's theory states that equal volumes of gases at the same temperature and pressure contain equal numbers of molecules. So if we take H2 gas plus Cl2 gas, results in HCl gas. If we balance the equation, the molar ratio would be 1 to 1 to 2. This also indicates that the volume ratio would be 1 liters, and 2 liters.
The question says, if the pressure and temperature are equal, how many liters of ammonia will be in 3.5 liters of nitrogen? Before we begin, we need to balance the equation, which is 3 hydrogens on the left side and 2 ammonia on the right side. So to begin, you would write the volume of the nitrogen, which is 3.5 liters of N2, times, so you would have a straight line across, and then on the bottom of the line, you would have nitrogen because you would want it to cancel out. And there's only 1 liter of nitrogen, and then on top you have 2 liters of NH3, and then you would times, divide, and your answer is 7.0 liters of NH3.
Example 2. If 4.2 liters of hydrogen reacts with excess oxygen, determine the volume of water gas formed if the reaction occurs keeping the temperature and the pressure constant. The first thing we want to do is write out the chemical formula. So we have hydrogen reacting with oxygen to form water gas. If we balance the equation, it would be 2 H2 gas plus O2 gas, resulting in 2 H2O gas. We are trying to find the volume of H2, and we know that there's 4.2 liters of hydrogen. To find the volume of H2, we multiply the 4.2 liters of H2 by the molar ratio of the hydrogen and the water. Since we are trying to get rid of the hydrogen, we put it on the bottom, and H2O goes on the top. Then we add in the coefficients, which is 2 and 2, and we get 4.2 liters of H2O gas.
Example 3. Gunpowder contains KNO3, known as saltpeter, charcoal, and sulfur. When heated or struck with a sharp blow, KNO3 decomposes to produce oxygen, which reacts with charcoal and sulfur. The decomposition reaction is shown by KNO3 solid, which is broken down into K2O solid, plus N2 gas plus O2 gas. Assuming both gases are measured at the same temperature and pressure, what volume of oxygen is produced with 15.0 liters of nitrogen, that is supposed to say. So first we would balance the equation. On the left side, we have 4KNO3 solid broken down into 2K2O solid plus 2N2 plus 5O2. Okay, so we've balanced the equation. Now we figure out how to find the amount of volume of oxygen which is produced with 15.0 liters of nitrogen. So first you would write 15.0 liters of nitrogen times, and then you have a straight line, and then you know on the bottom you would have nitrogen because you want the nitrogen, 15.0 liters of nitrogen and 2.0 liters of nitrogen to cancel out. So bottom 2.0 liters because you know you have 2 moles of nitrogen, and then on the top 5.0 liters of oxygen because you know you have 5 moles of oxygen. Then you would times, divide, and you have your answer, 37.5 liters.
Example 4. Calculate the volume at STP of each gaseous product formed by the decomposition of 3 liters of nitroglycerin. We have nitroglycerin breaking down into carbon dioxide gas, nitrogen gas, water gas, and oxygen gas. The first step is to balance the equation. That gives us the molar ratio of 4 to 12 to 6 to 10 to 1. We will start by calculating the volume of carbon dioxide gas. So we will have 3 liters of nitroglycerin multiplied by 4 nitroglycerin on the bottom and 12 carbon dioxide on the top. So if we multiply and divide, this gives us 9 liters of carbon dioxide gas. You can follow these steps to calculate the remaining 3 products.